Hi, welcome to question 3 of the Leaving Cert Ordinary Level 2025 Paper 2. So we'll get stuck in, and this is a circle question. So part A says the diagram below shows 3 circles labeled P, Q and R. So P is a small circle here around the origin, which is important. Q is a larger circle, again centered around the origin, and R is a separate circle on its own. It says write each of the letters P, Q, and R in the correct place in the table so that each circle matches its equation. Now, before we even look at the table, one thing we know about equations of a circle is that if the center is 0, 0, the origin, they don't have a value around the x squared and y squared. Okay, so both of these circles here would be either P or Q. Then we're focused in on this number on the right hand side, which is the radius squared. So we look then, what's the radius of P? Well, the diameter is 2 units. The radius is half that, is 1 unit. Okay, 1 squared, or the square root of this number, would give you 1. So the radius is 1. So this looks to me to be P. Now, looking at Q, the radius of Q is 3 units, like the diameter is 6. The radius is 3. 3 squared is 9. Or you could look at it like the square root of 9 is 3. That matches up. That this top one here must be Q. And then this circle and so on, this would have center, was it 6 on the X, 2 on the Y, which would represent these numbers here. And in the next part, we'll have to deal more directly with that. This is a radius of 2. So the square root of 4 is 2. So it matches up with our answers P or Q for the first one, or for the second one with the numbers, center not 0, 0. And P is the last one with center 0, 0, but a radius of 1. And that's it. Okay, so if you know about the equation of the circle formula, that this could be a pretty good question for you. Now, part B says the circle C, a different circle, has center 3 on the X, negative 4 on the Y, and radius 7. So we know for sure this does not have an origin or a center of 0, 0. So it's going to be the more complicated version. And then it says write down the equation of C. Now, the formula from the maths tables is x minus h all to be squared, and h is the x value of the center, so it's going to be 3, plus y minus k to be squared. Now, k is the y value. Now, there's going to be a trick here. Negative 4 by the negative here is going to change that to a positive. Similarly, the negative here by the positive is going to change that to a negative, which is a little bit of a tricky thing with circles we need to watch out for. And the radius here is r, so it's going to be 7 squared. Now, when I put the numbers in, okay, I've identified like on the page so the examiner can see it. That would definitely get you the attempt. Okay, the radius is 7. When I put them in, so the minus here by the 3 gives you a negative 3, whereas the minus here by the negative 4, that's going to be a bit of a trick, but we can do that by removing the brackets. And we always substitute a negative number in brackets into an equation so that if we have to manipulate it, it makes more sense. This is minus times minus, which will give a positive. Okay, and that's the answer. And the one last thing I'll say here is that there is often a penalty if you don't actually square the 7, which I personally think is kind of unfair, but I get it. That's the way they interpreted the marking scheme. So make sure to square that. Arguably, it's the simplest form, is 49. Now, the next part C says the circle K has center negative 1, 3. The point 2, 7 is on the circle, as shown in the diagram below. Then they say, find the radius of the circle K. And this is a pretty straightforward question. Now, this is only part 1 of part C. We're going to need to find the distance between these 2 points. And arguably the simplest way is to use the distance formula, although you could use Pythagoras by making a right angle triangle here. And then that would be 4 units on this side of the triangle. Was it 3 units on this side, and just use Pythagoras' theorem. But the distance formula is a variation of Pythagoras' theorem. And once we know the 2 coordinates, we can then put them in and label them first x, first y. second X, second Y. And it doesn't actually matter which point you label. As long as you're consistent in your labeling and your input, then you'll do good. Now, once I put those numbers in, so instead of the X2, I put 2, which we identified. Instead of the X1, I put -3. Now, I put it in brackets because it's a negative number. So when I do come along to use the calculator or however you want to do it, that the minus by minus there will change to a plus. On the far side here, the difference in the Y's, Y2 is 7, Y1 is 3, and they can go in without brackets because they are positive numbers. Now I'm working it down by hand, so this is 2 minus by minus is plus, so that's actually 2 plus 1, which is 3, and then 7 take away 3 is 4. This is the kind of classic situation here. 3 squared is 9, plus 4 squared is 16, 9 and 16 is 25. And then I square root 25 and I get an answer of 5. Now, I often recommend to my students just input the whole thing in the calculator with, so that's why putting brackets in is good. But I mean, arguably doing it down by hand is maybe just as easy. Okay, so that's part C, part 1. Now, part C, part 2 says, hence or otherwise, write down the coordinates of 2 points that are on the circle K other than 2, 7. Okay, now we can, in a way, not be tricky about this, but there's a few answers here that could work. And it says, give your answers in the form of A, B, so as a coordinate, where A, B are elements of Z, they're positive or negative whole numbers. And that's what a Z stands for. It means are they integers. So you mean you're not going to be looking, if you put in a decimal answer, it might be impossible to find that like with accuracy, but that's that. Now, if you think about it logically, like I know that the radius of this circle is 5 units. So if I went directly down, the X value is not changing. So that would be still -1 directly below it, but it would have changed by 5 units on the Y value. So I could put in -1, 8 as an answer. Now the ones I've chosen are directly across, okay? So this is 5 units away on the X value. So -1 take away 5 is -6. And the Y value doesn't change. I think the other answer I chose was going directly across. I just didn't put in a line for it. Going 5 units this way would be -1 plus 5 would be 4. And again, the Y value doesn't change. You could have gone directly up and you've got -1 plus 8. And you could have done a symmetry in here, but through the point on to this point on here. I can't think of anything else obvious to me in the second about what the options could be. So there's multiple answers, and as long as you're applying the logic or even the answer from the previous part, this question is manageable, but it can be a little bit extra tricky. Now, the one thing that's not on this year's question or last year's question 3, this year's question 3, is showing that a point is on a circle. And in that situation, let's say they were asking me to prove that this point was on the circle. I'd need to know the equation of the circle. And then if I just input the numbers instead of the X values, if I end up in a situation where the left-hand side of the equation is bigger than the right-hand side, it means it's outside the circle. If the left side equals right side, it's on the circle. If the left side is less than the right side, it means it's inside the circle. It's kind of the classic one they'd ask. This was a little bit tricky in one way, but if you understand the spatial orientation of what's going on, it's doable. If not, that's the test. Okay, so that's the end of question 3. As always, email shanetroy@gmail.com if you want a copy of these notes. Like and subscribe to get access to more playlists. Best of luck.